Today's lesson is on imaginary numbers. So, what is an imaginary number? Well, the square root of -1 is I, an imaginary number. So the idea is, up until today, you guys have always, whenever you're taking the square root of a negative, you would write no solution or not possible, no real solution. Well, in math, square roots of negative numbers pop up a lot, especially in quadratics. So the idea is, instead of just writing no solution all the time, we found another way to at least just communicate what is happening in these equations. It was debated for a long time if this was like an actual thing that we could use in math, and they actually have found applications of imaginary numbers. They are very helpful in describing solutions with quadratics. Okay, so I do want to talk about a little pattern when we are taking imaginary numbers, raising them to powers. So I is just I, and what that is, it's the square root of -1. I squared is the square root of -1 times itself. So that would be anything times itself, so that's like the square root of -1 squared. And when you square root, they cancel each other out. So I squared goes back to a real number. I squared is -1. Okay, I to the third, that would be square root of -1 times square root of -1 times square root of -1. Well, we just found out that 2 of these equals -1, and 1 of these is I. So I to the third power means -I. Okay, I to the fourth. So square root of -1 times square root of -1 times square root of -1 times square root of -1. So, 2 of them would be a -1. These two are -1. -1 times -1 is +1. So this is important in our next lesson, that I to the fourth always equals 1. And then also, I squared equals -1. Okay, 2 examples simplifying radicals or square roots. So let's say I have the square root of -144. I want you to think of that as -1 times 144. So the square root of -1 times the square root of 144. The square root of -1 is I, and the square root of 144 is 12. So this goes down to 12i. All right, the next one, square root of -8. So 8's not a perfect square, but it has perfect square factors. So I'm going to break this up into -1 times 4 times 2. So the square root of -1 times the square root of 4 times the square root of 2. This is I, this is 2, and then this just stays square root of 2. So 2i square root of 2. All right, so simplifying things with imaginary numbers. The first one is, if you have I to a higher power, what does that simplify to? So remember earlier on in the video, we had this pattern, and this pattern actually repeats. I to the 5th, this is the same as I to the 6th, the same as I to the 7th, the same as I to the 8th, and then it just keeps repeating. I to the 9th, 10th, 11th, 12th. We're going to use this right here, the fact that I to the 4th equals 1, to help us simplify this. So I'm going to break this up into, so I to the 4th. Let's raise that to a power that gets me really close to 42. It's not a perfect multiple of 4, 42 is not. But if I multiply by 10, that gets me to 40, and then how many are left over? 2. So I to the 4th to the 10th is I to the 40th. That's the same thing as 1 to the 10th. And 1 to the 10th is just 1. and 1 times anything, so it's just I squared, and I squared is -1. So I to the power of 42 will be -1. All right, now a different type of question. We're going to do 6i times 3i. So think of this as 6 times 3 times I. So this is 18i squared. Well, what is I squared? Over here, I squared is -1, and 18 times -1 is -18. All right, let's now do -2i times 5i. That's the same thing as -2 times 5 times I, -10 times I squared, which is -10 times -1, which goes to +10. Okay, 2 more examples, and it's going to involve solving quadratics. Okay, so, but they're pretty simple quadratics. 2x squared plus 32 equals 0. So all of these in this lesson, they don't have that middle term. They're all in the form ax squared plus c equals 0. We don't have the middle term. So one way to do this is just simple solving. So minus 32 minus 32. 2x squared equals -32. Now divide by 2. So x squared equals -16. And then to finish solving this, to get x by itself, what's the inverse of something squared? It is square rooting. When you are solving for x and you're square rooting, you always have a positive and a negative version of your answer. And the square root of -16 is 4i. Okay, last example, 3x squared plus 12 equals 0. Same idea, minus 12. So 3x squared equals -12. Divide by 3. So x squared equals -4. When you square root, x is equal to, you always need the plus and the minus, and this is 2i. So there is your full video on kind of an introduction to imaginary numbers. Good luck.